right, and a big warm welcome to Emily, who's going to give us our next talk about rolling boulders forever uphill.
Do you want to just put this in your back?
All right, do we got it up here? Oh my God, it's huge. Hey all, good morning. Good morning. This is Rolling Boulders Forever Uphill, DevOps with Docker, Kubernetes, AWS, and custom Slackbots. So a little bit about me. I am the Senior Vice President of Engineering for Upside Travel. We're a new DC tech startup. For those who want to know, we're at 16th and L, so downtown. Personally, I am a huge systems junkie. That means system architecture, distributed systems, but also people and process, and anything that has a lot of moving parts catches my interest. And you can always contact me at emily@upside.com, or you can follow me at Twitter at Multiplexer, but good luck with you if you do that. No warranties on that Twitter feed. So I don't usually read slides verbatim, but I'm going to read this slide verbatim just this one time. The gods had condemned Sisyphus to ceaselessly rolling a rock to the top of the mountain, whence the stone would fall back of its own weight. They had thought with some reason that there was no more dreadful punishment than futile and hopeless labor. That's The Myth of Sisyphus by Albert Camus. There's a little bit more from Camus. You've already grasped that Sisyphus is the absurd hero. He as much through his passions as through his torture, his scorn of the gods, his hatred of death, and his passion for life won him the unspeakable penalty in which there's no being is exerted toward accomplishing nothing. That is the price to be paid for the passions of the earth. And that is a marvelous metaphor for DevOps. And that is why we named our system Sisyphus. It's great, right? It's the hardest problem in engineering, right? Is naming things, right? So it's good if you've got a minor in philosophy, and you can name it after Camus. This is Sisyphus as of about a week ago. It's running in Slack, has a nice little icon, Slack mode. It is a Slackbot. It is the hub for all of our DevOps through our entire system. It does all kinds of stuff. You can promote through staging and production. You can diff different versions in staging and production and dev. You can restart Kubernetes pods. You can look up people's roles. You can reset roles. You can get versions, you can get git-shas. It does everything. It slices and dices. It's a really, really powerful little tool. But so what does it really do? What is its point, right? Sisyphus's point is to central all of our DevOps into ChatOps and to put the entire build system into the hands of non-technical business owners so that it frees up engineering and DevOps to go do the interesting work. We do not need anybody to go and poke our DevOps team to go and deploy something to someplace. It's our product, and our QA teams can do that for us. And not all, it's a Slackbot, so we can ship 24/7 off our cell phones from apparently a Subaru dealership. We can restart Kubernetes pods. We can kick off integration tests across the entire top of the platform. We can show versions between one deployment environment to another deployment environment, or we can look at image versions, and we can ship literally any of our code anywhere at any time. And we do not need to be involved in that process. And it reports back to Slack when it's done. But in the beginning, so, sorry, I lost my speaker notes. In the beginning, the universe was created. This made a lot of people very unhappy and was widely regarded as a bad move. So when we talk about DevOps, we talk about originating states, right? So every system that we build, every build system, platform, deployment pipeline has to start from some sort of originating set conditions. And based on what those originating set conditions are, determines if your universe is going to be full of life or if it's going to be completely barren. So what we started with when we were talking about our original starting conditions was this. We made an initial decision at Upside to go 100% cloud native. We've never had a server in-house. It's a great trolling device, though, for people who don't understand the cloud. You can tell them that the servers are all under people's desks. We picked Node.js. We are still in Node.js shop. Node.js Express and AngularJS with Webpack. Hilariously, we went Webpack to Gulp to Webpack. We're back on Webpack. We picked Circle CI. Circle CI works like Travis or a Drone IO. It's different than a Jenkins or a TeamCity, where all the deployment is based on GitHub repo. It's not based on any rules-based engine. Regular SES-based GitHub, and at the time we were doing manual deploys to Lambda S3 and API gateway. We were doing everything by hand via ye old FTP method. We built some core philosophies into our platform when we started. The big one was immutable infrastructure. Not allowed to go into systems and change them, they just die. So if you're not familiar with the pets versus cattle, pets are when you go and you continuously feed all of these systems, and cattle is where they go as a herd. But we were a little bit more aggressive than that. Literally nothing is allowed to live. If something changes, it just dies and then it comes back from the dead instantly. So that was the core philosophy. Another big one that we use is we use AWS until AWS breaks, and then we just simply replace it with some better tool. Interestingly, this happens all the time. Code is infrastructure, not allowed to go into the AWS console and click on any buttons under any circumstances. It has to be all code all the time, has to go into Git, has to have a PR, has to have revisions. Hardcore. And that core philosophy is we would automate all the things. So the first iteration of the system made the core decision to go with separating our environments by account instead of across VPCs. It makes it much cleaner to set up segregated environments. We built EC2 golden images for as we moved out of Lambda and went to EC2 so we could have a base image to work from. Decided to use HashiCorp Packer to build the AMIs and automated that through Terraform Enterprise. We had to use Terraform Enterprise because we had more than one person working on the system, and as you know, the open source version of Terraform saves the TF state to your local hard drive, and we had to have it shared, so it shared an S3 bucket. We use HashiCorp Atlas as sort of the main command center, and then we simply leaned into every single three-level acronym that was on AWS. So VPCs, networking, the security groups, EC2s, ELBs, launch configuration, and autoscale groups, which is very important. Aurora, Redshift. So if it was available in AWS, we started using it immediately. Interesting fact, we don't and never have used any of the standard configuration management tools. We do not use Chef, Ansible, Puppet, or SaltStack anywhere in the entire system, which removed a dependency, which is very nice. So this is the Rube Goldberg machine. That was the first iteration. It literally was a self-replicating napkin. How it worked is you would go ahead and merge all your code into GitHub, and then Circle CI would see that it was going. It would go ahead and kick off the build, and then from there it would kick off Terraform Enterprise, and then Packer would wake up, and it would start cooking an AMI, and it would go and it would cook and cook and cook and cook and cook, and then Terraform would go and do the whack and replace method. If you don't know the whack and replace method in Amazon, it's a very clever trick where autoscale groups knows that it has to have a certain number of a certain AMI in its launch configuration that it sets up, and launch configuration is based as a tag, and it will take whatever is the newest EC2 that comes off the line out of the AMI registry. So you can simply just go and kill it, and it will launch the newest one that happened to be built. If we weren't putting something out on EC2 and we were still putting things into S3 buckets, we'd have Atlas go ahead and put things into S3 and Lambdas. The AMI was the unit of deployment, and we used the copy and replace method for AMIs to be able to do full promotion. And you know what? I'm going to be truthful. This worked. This actually worked. And a lot of times, this is it. This is the end of the talk, right? This is it, we're done, walk out, right, victory. I can push a button, a thing runs, and I get a thing at the end, and it generally does websites. And frankly, for a small website, it's perfectly fine. But it wasn't fine for a growing company. We had all sorts of really insane, crazy issues. Favorite was the 25-minute deploys. Packer takes its time. It is not a fast way to cook something. And the best thing was that Packer would occasionally go at the end of it. Actually makes that noise. And it always fails at the 23-minute mark of a 25-minute deploy. It's amazing. It's remarkable, right? So you have something that's really critical. It needs to go out, and Packer decides that the AMI API just isn't available that minute, and it just fails. So that's a great thing with Packer. It's a great tool, but just beware that it's moody. We had, I say 1 million EC2 micros at one point as we had the system chunking out micros. We had 250 EC2 micros running in dev alone, and that this was not going to be long-term sustainable. And that was 250 micros, and we had maybe 6, 7, 8 microservices at that time. So at some point, we were going to have 1,000, 2,000, 5,000 micros. It was just going to go. I mentioned that we used AWS API Gateway. AWS API Gateway committed hideous suicide on us. It just decided one day that you could not script production configurations anymore, and it just wasn't going to do it. 6 hours on the phone with AWS later, we threw it out. AWS Lambda died in a different way, but unfortunately, that's a topic of another talk. And I want to talk for 1 second about the DynamoDB thing. We use DynamoDB as the world's worst service discovery. This absolutely 100% works, right? This works. You should, if you don't want to get etcd up or you don't want to get console up and you're looking for some way just to be able to do some service discovery from environment to environment, I'll tell you, DynamoDB works absolutely. The only problem with it is that it doesn't actually encrypt anything, so if you want to put some secrets in it, they're just open to the public, you know. So secrets, we didn't really have secrets. So enter Sisyphus. At this point, we were making with the clicky, and every time that one of our deployments failed, we had to open up 17 windows to try to figure out what was going on. So enter Sisyphus. At this point, that's why we named Sisyphus for KMU. It's written in Go, still written in Go. At the time, it ran on EC2 micro. It was a really nice bridge between the Packer, the Terraform, the EC2, the APIs, everything. It would report exactly if it came in and if it failed. And it was the first time that we could actually start putting our entire DevOps process into the hands of our product people. So we could spend more time figuring out what was going on and exploding and spend less time trying to, oh, you want to ship these 15 things. All right, let me drop everything and ship these 15 things. So that stabilized our system, and that was terrific. So from there, we moved on. And we're to the second iteration. So at this point, containerization cometh. So the containerization machine has come to us. This was the time that we realized that the 250 EC2 micros wasn't really a sustainable thing. We were already on JFrog Artifactory for the NPM issue. We are a node shop, and we were getting library drift already really bad. So we would have, two microservices would have two completely different versions of the same library. So that was already something that was in place and something that we could leverage. We had to pick the OS for containerization. We picked Alpine Linux. It is a version of BusyBox. It's very nice, very simple, very clean, highly recommended. We got rid of Packer and moved over to Make Image. A big change for us was getting rid of AWS Gateway and going to Kong. Kong is a Lua plugin in Nginx that will basically works exactly like AWS API Gateway. Make an entire gateway look like one continuous platform. So you could keep shoving microservices underneath it, and it just looks like one giant API REST interface, which is how we operate the platform today. We didn't use HA proxy. We went to Traffic. Traffic is a little tiny, hyper-fast reverse proxy that does dynamic loading of configuration. It's written in Go. Pretty much at this point, if you're in DevOps, you should learn Go because all your tools are now written in Go. It's terrific in every way, and we moved rapidly from some of the fat monoliths that we were building to a single-serving microservice platform. But we can't actually stand up any kind of containerization solution without having an orchestration decision. At the time, we picked the 5 top orchestration services that were available to us. Because we were following the commandment of everything has to go in AWS until it breaks, we tested ECS, Elastic Container Service, Kubernetes. My horse that was in the race was Nomad. Rancher, and Docker Swarm. And we did the bake-off on 13 major dimensions. The synchronization, right? Does it use etcd? Does it use console? Is it just backed by Dynamo? Or does it put all of our stuff? Does it auto-scale, right? Which is huge in a live running production environment. Does it have a CLI tool? Does it have local parity? If I download the entire system to somebody's laptop, can they run chunks of the laptop exactly like it is up in the cloud? Does it have a pretty management UI? Yes, no. A big one really for us for Phoenix architectures is node draining. So you don't want to vaporize Docker containers and still have somebody in there using them. Your platform will get stutters. So we need to make sure that all the connectivity was out of the container before we vaped it and brought it back up. Rolling updates is really big too in a production environment. You don't want to need to take down your entire production environment just to upgrade your Docker orchestration system. So rolling updates was big. Secret management, I just mentioned secret management, really nice if we had secrets. We have connections to airlines and hotels. I don't think we want those passwords to go out on the internet. So having secrets management is big. And of course, right, so we're doing containerization, service discovery is everything. So we looked at all 13 of these dimensions and we stood up all 5 of these actually. And we picked Kubernetes. Kate's works great. It supplied every one of those 13 features for us. A huge plus in instruction is the built-in DNS-based service discovery. If you've spent a lot of time working in the cloud or working with AWS, you know that service discovery is huge. Everything that's in there is DNS placed. Secret storage, right? etcd's has secret storage, and we can pull it right out of private repos, so we don't need to keep pushing secrets into DynamoDB. Dynamic volume mount sources. If we're mounting GitHub for secrets or we need to expand space, it can dynamically mount EBS or GitHub. It's really nice that we can write some code and be able to deploy an entire unit as one thing, especially because our various applications come in chunks of these microservices, so now we can programmatically start actually deploying those to, out to the cloud. And yeah, so it's really nice because we can do a bunch of API versioning, which is really important if you happen to be writing mobile apps. Because if you put mobile apps out and you change your API underneath it, your mobile apps will break and all of your customers will be sad. So this is where we are today. I'm like usually used to at this point, like gesturing over this, but it's really far away. So you have to watch me do this for a minute as I try to get my bearings. So this is what we look like today. Our Kubernetes hosts are EC2 hosts, right? They're spread across AZs. They're in, you know, launch configuration and auto-scaling groups. It's the same architecture as we had before, just more so, right? So a customer comes in. If they're coming in, they're hitting the head. They'll hit CloudFront and then hit S3, and then they'll go and they'll get whatever. But if they're actually going ahead and making some sort of REST call, they're going to pass through an external ELB, and the external ELB is pointing at Kate's masters. Those Kate's masters are talk to Kong, which has all the routing in it for where everything lives on side of the API. And then it talks to traffic, and traffic is the reverse proxy that finds the containers behind it and gets it into the container. And we do a full injection of environment variables and secrets into the containers as they come up, so everything is very self-contained and very nice. What's nice about this system is that it not only is very fault tolerant because it scales across AZs, but it also auto-scales really nicely. And the nice things about Kubernetes is that we can add more EC2 hosts in one of the various AZs and then start deploying Docker containers to it. So we can very smoothly add more capacity to our system and put more containers on those systems as we grow and as we scale, which is happening like bazinga right now. Some benefits of this, 3.5-minute deploys. That is not how long it takes to build. That's how long it takes to go from a GitHub PR to master all the way out to prod. The fact that I know exactly how long it takes for something to go to GitHub master all the way out to prod is probably telling of a system of a startup. And most of that time is us actually typing the commands into Sisyphus into Slack. It could probably send things out faster than that. So we are deep into the Docker packaging story, right? It's the big thing that containerization brings to the table is this beautiful packaging story where everything's in a very nice, neat, contained piece. So we lean into that very heavily. So every container is its own microservice, which is very cleanly wrapped around. We inject the environment variables into the container so we don't have environment variables floating all over the place. It's very clean to have a dev, staging, and master. We have better secrets management. We've actually managed to get secrets from LastPass slurped into the secrets management in K8s and then into the containers so that we have them all the way out into LastPass where everything is secured. We obviously get better usage of our EC2 hosts. When we were on EC2 micros, right, I think we got 0.1% utilization out of those things. Now we have something a lot more consistent. We no longer have Packer going in the middle of a deploy. And a big thing for our developers is local parity, that they can just go up in Artifactory, grab images, pull them down, run them locally on their desktops, and they have exactly what is running in production. So there's no real mystery of what is running on production. So it's all pretty cool. So now we are to the current iteration. Today, this is our build pipeline. Today, this is what we do every day. It's actually going off on my phone right now. I can feel it. So on the furthest left-hand side is sort of our control surfaces. We are really, really deep into chat ops. Everything in the universe comes into Slack. It's the perfect control surface for all sorts of reasons. Sisyphus is integrated with Slack, and we do a lot of the project management with Jira, so everything has tickets on it, and we just track it through all of the pools. So development is the merge, goes to GitHub, and then we do a build, we do a test, we have unit tests, SNCC for security tests, some linters that go on. We build an image, push it up, and publish it up to JFrog Artifactory, and then we deploy it to Kubernetes, and then it goes to Docker containers. And we largely are the exact same thing all the way up the pipeline, except, right, we use TestRail just for a case management system. So this is what our system looks like today. This is sort of talking about Sisyphus. Interesting factoid to take away from this. It takes much longer to do the old HashiCorp Terraform deployment to S3 in Lambda, even though we absolutely still support that. We absolutely use Lambdas. Much longer than to drop a Docker container. It's minutes difference, so if you're, it's a 10-minute versus a 2-minute thing, it still takes its time. Anything that goes directly to an AWS service still takes its time to do it. Sisyphus integrates with CircleCI to find state. I mentioned Rainforest down here. It's a SaaS you should look at if you're looking at automating any of your QA. It's really cool. It talks to Kubernetes through the kube control and kexpand commands and does all the dynamic hot loading in the back end for traffic in Kong. Also does all the coordination to be able to pull the images and drop the images on the system. So everything about all the networking in the back end, the deployment, and of all the containers is all completely 100% automated. And like I've said a couple of times, all of our secrets are sitting in GitHub or sitting in LastPass. And last but not least, Sisyphus is great because it logs a lot. That's really cool. We can go and pull up its logs and see exactly what it did at any time. It also reports all the way back into Slack to say exactly what it did, why it did, and what it did at any time. Here's where we're kind of our today's state right now. So right now, today, we have engineers will edit up various K8s definitions to dynamically add microservices to the entire system. And we have this insane fish script that goes out and builds an entire repo. It creates the GitHub repo. It puts all of the Node.js framework in there, all the boilerplate. It has logging. It has a /info route, so we can see if it is up. It will kick off the build system, create a Docker container, and drop it. So from a point of an engineer doing a PR on a K8s definition file, we can have an instant microservice that is deployed to dev, ready for an engineer to go and simply color in the lines. So that's the point that we've gotten to with this system. And product can, will, and it's going off on my watch right now, push completed code to staging and production from Slack, which they do all day long. We give product the sign-off powers. We have to give them some power so they feel good about themselves. And so my last line here, which says that we're doing 4 to 8 production deployments a day, is a little bit of a misnomer. On an average, we are doing 4 to 8 production deployments a day. And this is code that goes to production, not code that we just started standing up in dev. So this is it in Splunk. This is what are you? You're Sisyphus. This is Sisyphus in Splunk. It's a pivot table. It's very fancy. It shows essentially every single line of everything that we do. We actually publish 12 to 15 times a day on a Monday and Tuesday. And the reason for this is we have sprint planning on a Wednesday. So everybody's trying to get their tickets to done. So we have this huge spike at the beginning of the week. And then on Fridays, people are like, I don't want to ship to production on a Friday. That seems like a really bad idea. So on average, we have 4 to 8 deployments a day on a week. In reality, we have 12 to 15 on a Monday and a Tuesday, and like 2 on a Friday. Is everybody's like, no, don't do that. I don't want to do anything on the weekend. So I'm running a little short, so I'll have some time to answer some questions. But I just want to talk about the various pieces of technology that were in this talk that you should go, and I see a lot of you staring at your phones, so you should just put these URLs in. If you are in DevOps, right, please go learn Go. Everything is written in Go. Seriously, Docker's in Go. Kubernetes is in Go. Traffic is in Go. Yeah, okay, Kong's in Lua because it's weird. Somebody who liked writing, World of Warcraft plugins must have built Lua. But everything else is in Go. New queuing systems are all coming out, are all in Go. So please learn Go. Kubernetes is still, I think, the leader in container orchestration. HashiCorp Nomad's done a really good job lately of catching up to parity. They're worth taking a look at if you want to be fully in the HashiCorp ecosystem. But right now, if you want everything I put on the slide plus more, it's what Google uses to run all their operations. Obviously Docker, right? Artifactory, there's a couple ways that you can put your images up into AWS. You can put them in S3. I like Artifactory. It's really nice. It's got really nice APIs. Traffic is, again, written in Go. It's a miracle of science. It's really light, really fast, and dynamically loads all the dynamic port mapping instantly. So please take a look at that. Kong has some fiddly bits to get it working, but it makes a really nice API gateway across the top. We rely on it. It's terrific. We're still a Terraform shop. Terraform controls all of our architecture. It's sitting in GitHub. People take PRs against it. I can recommend Terraform as if you need your infrastructure as code. Alpine Linux, and obviously, if you want to get a big dose of existentialism that is DevOps, Camu's on the bottom, the myth of Sisyphus. Could not do this without these guys. Jay's actually right here. He's on my slide. He's very embarrassed. I was happy to embarrass him. He's our lead DevOps. I guarantee you he can answer every question that you have. Any I can't, he can answer. Phil Armour is our chief architect. He's holding the fort right now at work. Dennis Webb is lead DevOps for Blue Sentry IT. I'm going to give a small plug to Blue Sentry. Kenneth will love me for this. If you need an IT outsourcer shop, let me tell you, these guys are terrific. And of course, our TAMs, who we love to torture because we have broken every service in AWS at least once. And that's it. We're upside. Go here. We are hiring. I do have a senior DevOps opening. But we're hiring for literally everything under the sun. So we're a travel company. We're doing really cool stuff. Travel looks boring on the outside, but it's really cool on the inside. And that's it. I got 1 minute. Any questions? Yes, sir.